the first law of motion or the law of inertia. Galileo was interested in the causes of motion and was among the first people to perform a systematic study of the phenomenon using experimentation. He noticed that when objects rolled up an incline, they lost speed. Conversely, when objects rolled down an incline, they gained speed. Galileo also noticed that a marble that rolled down from a height on a downward plane would then reach approximately the same height when rolling up another upward inclined plane. If the slope of the upward plane was decreased, the marble would roll farther. If the slope of the upward plane was increased, the marble would roll a lesser distance. But interestingly, in every case, the marble would attempt to reach the same height from which it was released. If there was no upward or downward inclined plane, Galileo deduced that the marble would keep rolling forever, its speed neither increasing nor decreasing. This led Galileo to a crucial insight that challenged the existing ideas of the time. What would happen if a moving ball was rolling on a plane that slanted neither up nor down? What would happen if the ball was on a perfectly flat surface with no slope? The answer was intuitively obvious. The ball would neither speed up nor slow down. The ball would keep moving at a constant speed forever. It seemed to follow that an unbalanced force was needed to initiate motion, but once begun, the motion should theoretically continue forever. The reason the marble would eventually stop in real life was because the frictional force that gradually reduced the marble's energy, because friction always opposes motion. If friction could somehow be removed, the motion would continue unimpeded forever. This is actually seen in outer space, where there is no friction due to the presence of a vacuum, and an object once in motion will remain in motion indefinitely. The motion of satellites around the Earth is a good example. A pendulum placed in a vacuum will similarly oscillate for a long time, going back and forth again and again because of the absence of friction to slow it down. Sir Isaac Newton, who interestingly was born the same year Galileo died, studied the latter's ideas intensely and applied his high mathematical acumen to formulate the first law of motion. An object remains in a state of rest or of uniform motion unless compelled by an external unbalanced force to change its state. Thus, the first law is telling us that objects tend to resist any change in their current state, whether it be rest or uniform motion. This property of all objects is known as inertia. And this is also why Newton's first law is also known as the law of inertia. Let's look at some practical examples of inertia in daily life. When we accelerate a car, we feel as if we are being thrown backwards. This is because the inertia of our body is resisting a change in its state. When we apply the brakes, our moving body is resisting a change in its speed and wants to continue forward at the same current speed before the brakes were applied. Thus, we have both the inertia of motion and the inertia of rest. When we take a sharp turn in a car, we feel as if we are being pushed in the outward direction of the turn. This is because our body wants to continue on that same straight path as it was before. This is the inertia of direction. From a quantitative standpoint, inertia is identical to mass. The more massive an object, the harder it is to change its state of rest or motion. A small, light marble can be made to move fast with a little force, and a moving marble can be slowed down or stopped by applying relatively small forces. But an iron ball at rest needs a lot of force to get moving, and a moving iron ball will require a lot of force to turn or to stop. Based on the fact, we may say that the mass of an object is a measure of its inertia. Coming back to an earlier point, this also answers another question. From a physical standpoint, a state of rest and a state of uniform motion are indistinguishable depending on our reference frame. An object feels an inertial force only when its state of uniform motion is changed. In other words, an object feels a force only when it is either shifted from a state of stationary rest to motion, or from motion to rest, or if its speed is changed in some way.
So let us see if we can summarize whatever we have learned so far.